reaching the end of our unit. We started with a PO. We end with a PO. This one's PO15. And you can see the objective is simplifying an expression using multiple rules. We've learned 5 of them. Okay? And if you look down at what the homework is here, you can see that every question has got multiple things going on. Maybe it's multiplying by the same base and a fraction. Maybe it's distribution with negatives. Maybe it's multiplying by the same base with negative powers, right? Maybe it's multiplying by the same base with dividing by the same base with 0 powers, with negative powers, with distribution. Maybe it's all 5 of them, right? And so my advice to you here, and I said this when we were correcting homework, is that as long as you do something, you'll end up doing everything. Anytime you have more than one of the same base, you can always combine them. Anytime you've got parentheses, you can always distribute. Anytime you've got a negative, you can always move it. Anytime you have a 0 power, you can always ignore it, right? There are clues here that we've talked about that are going to help you through this, but just do something. Just do something. But let's review. This is a key point. It can go on a help sheet. It's a nice summary of all the rules that we've talked about. In this, C refers to what happens to the coefficients. E refers to what happens to the exponents. And B refers to what happens to the base. So, in multiplying by the same base, what happens to the coefficients? Great start. In multiplying by the same base, this is CO10 right here. Okay, it looks like this: 4n to the 5th times 3n to the 7th. That's an example of multiplying by the same base, and you know that because the multiplication symbol is literally there, right? That's the hint. What happens to the coefficients?
They multiply.
You multiply them. Coefficients are multiplied. Exponents are added.
Stay the same.
Bases stay the same. Okay, that's the rule in a nutshell. For dividing by the same base, when you have a fraction, right? When you have a fraction, if it's 8n to the 5th over 6n to the 7th, you've got a fraction. What happens with those coefficients? Simplified. You can also think of them as being divided, but remember, if you've got coefficients that don't divide evenly, like 8 and 6, I don't want a decimal, right? Don't actually divide them. You simplify them. You become 4 over 3. Okay? So they're simplified. Exponents are subtracted. And the base, once again, stays the same. So this one would be CO11 here if you wanted to look back at that. Okay? A 0 exponent, for example, whether you have a numerical base or a variable base, coefficient, if there was a coefficient here, such as 9x to the 0, what would happen to the 9? This is the one rule where the coefficient stays the same. I guess negative powers is similar, it stays put. But in this rule where the base changes, the coefficient that's not affected by the power stays the same. The exponent, obviously, it's a 0, right? That's kind of how you know it's a 0 power rule. And what happens to the base? Becomes a 1. That is back in CO12. Becomes a 1. Okay. Negative exponents. If you've got something like 2n to the negative 7th over x to the 4th, what's going to happen to that 2?
It's going to go to the other side.
It is not, because that 2 is a coefficient. The 2 stays put. The coefficients do not move. They are not affected by the negative power. It stays put right where it's at. The exponent moves and then becomes positive. Okay? Moves and becomes positive. Where does it move to? Just the other part of the fraction. Remember, a negative exponent simply means it's in the wrong part of the fraction. Okay, so we move it, we make it positive. That was a good action shot right there. I bet that's going on Facebook. Then the base of that negative power, that n, what happens to the n?
It moves to the other
Moves
side
with
of
the power.
Wait, what does the E do?
It moves with the power.
Moves with power.
The exponent moves and becomes positive. Right? That n to the negative 7, that negative 7 gets moved to the other part of the fraction and becomes positive 7. The base of n goes with it. Okay? A negative exponent simply means the base is not in the right part of the fraction, so we move it. And then lastly, CO14, distributing an exponent into parentheses. I've got VC because this stands for, well, they're all part of the base. I really shouldn't have a V there. I think I should change that. But the coefficient with parentheses, remember, it gets the power. Takes on the power. The homework that we just corrected would be an example of that. If we have -4 n to the 6th, and all that's being taken to the 7th, right? When we distribute that 7 in, that coefficient 4 gets the power. Okay, it becomes 4 to the 7th. What happens with the exponents? They get multiplied, right? 6 times 7, we get n to the 42nd power. And the base stays the same. That n does not change. And those are basically all the rules summarized for you, all 5 that we covered. And remember, they all give you a hint as to what they are. Multiplying by the same base literally has a multiplication symbol in it. Dividing by the same base literally has a fraction. A 0 power has a 0. A negative power has a negative. Distribution has parentheses. Okay? They're all there to help you. Go ahead. So, pick one to talk about. Let's do the first row first. We got time for one. Let's do the second one. So this is actually very similar to one you had on your homework. I just changed the. It's still a 5. I changed the a to the 0 to a to the 4th. But it's the idea here that you see parentheses, right? And so you're going to need to distribute. Could you move these powers within the parentheses first? Yes, but the downside of that is you'll just have to move them back again anyway, because all the signs are going to change because what you're distributing in is a negative power. So in this case, if you simplify within the parentheses first, it's counterintuitive because you have to move everything back when you're done. Because when you distribute 5 to the negative 2nd, now 5 will need to be moved, right? A to the 4th doesn't need to be moved until you distribute. It becomes a to the negative 8th, and now it will. It just changes everything. B to the negative 3rd becomes b to the positive 6th. Now that's going to stay put. And c to the negative 8th becomes c to the positive 16th. Now that's going to stay put. Again, you did something. You distributed, right? Now you look at, what else can I do? You see negative powers. We're going to move those. B to the 6th, c to the 16th over 5 to the positive 2nd and a to the positive 8th. You've done something else now. You've taken care of the negative powers. So your last step is to see, do I have any of the same base that I can combine?
No.
Any more A's, any more B's, any more C's? The answer is no. So you're done.
Yay.
Okay? The last one. One like this, I would recommend simplifying within the parentheses first. especially considering our exponent's positive. It's not going to change the signs of anything. So if we take care of any negative powers now, we won't have to move them again later on. So tell me, again, let's just do something. Tell me something we can do inside of our parentheses.
Offset to 0.
We can take care of the 0 power. Doesn't need to be there. Excellent. Do something else. I'm hearing murmurs. Yeah, right, James?
You can combine the x,
Sure.
the x, and the n with the n.
The x and the n with the n?
No. N with the n.
Yes.
The x with the n.
Good. So James is saying we've got like bases here, right? We've got 2 bases of n and 2 bases of x. Why can we combine those even though they're parts of different fractions? Because they're the same. And how do you multiply fractions? How do you multiply fractions?
You have fractions.
You multiply straight across, right? So really what this is saying is n to the 9th x to the negative 3rd over x to the 7th n cubed. I can combine those 2 fractions together because how you multiply fractions, you go straight across anyway, right? So I'm still multiplying n to the 9th by x to the negative 3rd, whether they're 2 separate fractions or written as one, the same thing's happening here.
Wait, why just combine?
Because all you do to multiply fractions is go straight across, right? So if I multiply these fractions, I'm multiplying n to the 9th by x to the negative 3rd anyway. So why not just write them as one numerator? Because that's what this says here. This says n to the 9th times x to the negative 3rd. Same thing here. X to the 7th times n cubed, I multiply straight across anyway. So just write it like that. Okay? I mean, let's say there are fractions where, 9/7 times 2/10. You'd multiply straight across. Couldn't you just write this as 9 times 2 over 7 times 10? Yeah. 9 times 2 is 18. 7 times 10 is 70. When you multiply fractions, you can just write them as 1 with multiplication because that's how you do it anyway, right? So now we're here. James is saying we can combine these bases. Evelyn, give me, how can we combine our bases of n's or our bases of x's? What do you see? Well, I'm only going to move my x to the negative 3rd because that's the negative power. And if I move that x to the negative 3rd down, how many x's are in my denominator now? 10. Right? There are already 7 in the denominator. If I move 3 more down there, now I have 10. Right? I bring those negative 3 down, become x to the positive 3rd, combine them with the 7 that are already there, total I have 10. How do I combine the ends? I've got 9 up top, 3 on the bottom. I see it's a fraction that triggers dividing by the same base. Mario?
You subtract 9 minus 6.
9 minus 3, right, to get 6, right? And where are those 6 ends? Are they in the numerator or in the denominator? They're in the numerator.
Red tomato.
Right? So combine my ends here. It's a fraction. I've got some up top, some on the bottom. Dividing by the same base, that rule, 9 minus 3 is 6. Or just think about it. How many more ends do I have and where are they? Okay? Who have I lost with this? Where did I lose you? Yeah, so I'm seeing here I've got 2 bases of n, right? I see it's a fraction. Some are up top, some are on the bottom. So I think about which rule involves a fraction. That's the dividing by the same base rule, CO11. That rule says the powers are subtracted, 9 minus 3 equals 6. These 3 ends will cancel out with 3 of those 9, leaving me with 6. In expanded form, n times 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 n. There's my n to the 9th. Over n times n times n. There's my n cubed. I've got 6 of them left. Okay? Now I can distribute, and I gotta let you go here soon. But now finally I can distribute in the 5 my final answer, n to the 30th over x to the 50th. Okay? Finish just this side, just this page of PO15 for tomorrow. We'll worry about the second page tomorrow. Homework, finish this page for tomorrow. That is how you math.
Don't forget to like and subscribe.